Okay, everybody, this is chapter 9, section 1. This chapter is about taking different figures. Typically, we'll do a triangle or points or a line, and we're going to move them on a graph. So there's a bunch of different ways that we can do that. So as this chapter goes along, we're going to see how we can take something and move it to a different part of a graph and do it in different ways. At the end of the chapter, then we'll also look at how we change the shape of a particular object. Okay, so the section's called translations, which is making something move. It's a specific one, but there's a kind of a broader, I call it an umbrella, a broader term that defines all the different kind of movements that we're going to do in this chapter. Okay, so that the first one is transformation, and the definition for that is this. So a mapping that results in a change in the position, shape, or size of the figure. Okay, so mapping means, you know, I have a graph and I have something on the graph and I'm going to move it somewhere else. So we're using the graph, our Cartesian plane, we're using that as a map. Okay, so that it says it changes the position, so we are going to do that. We will change the shape and we'll change the size. That will come a little bit later in the chapter. Okay, we're going to stick with something called a rigid motion though to start off with. So a rigid motion is going to be keeping distance and angle measure. So like if I'm working with a triangle, let's say I have a triangle that I've mapped onto a graph, but I'm going to move it somewhere else on that graph. I'm going to keep the side lengths the same length, and I'll keep whatever the angle measures are, I'll keep them the same angle measure. Okay, so a rigid motion means it's just the same thing, just in a different place. Okay, a couple of terms that go with a transformation, or a transformation, in this case a translation, is image. Okay, image is like I call it the new figure. Okay, it's the result of a transformation. So I've moved it in some way. Okay, we're talking about a translation here in the first section. The next section we talk about reflecting something, and the section after that we actually rotate it, and then we do a couple of we do like 2 moves at the same time in the later section. So an image is you were over here like in the first quadrant, and somehow I got you over into the second quadrant where it ended up is the image. The pre-image is where I started. Okay, so I had like a point or a line or a triangle, whatever it might have been, whatever my picture was, basically. This is where I start. So I'm in the first quadrant, I call that the pre-image. I move it into the second quadrant, and we'll learn how to do that in a little bit. When I move it to the second quadrant, that becomes the image. Okay, so we have a starting place, and we have like an end place. Okay, so in this chapter we're talking about translation. Okay, so this is our first, I'll call it a movement, and this is how we're going to do it. A transformation is going to map all points of a figure in the same distance in the same direction. Okay, and just to kind of get ahead of myself a little bit, this is kind of like what pilots do when they fly a plane or when people sail a boat on a body of water. They translate. I'm here right now, and I need to get to this point over there. So like, you know, I'm going to get in the plane in San Francisco and fly to LA. So I have to translate this plane. It's not going to change anything, but I got to translate it from here to there. So pilots kind of use a variation of a translation. They call it vector, but it's the same thing. Okay. All right. So if we could write down this A and B Just write down the question. We'll talk about it. Once again, too, I try to go fast in the videos for time's sake. So please, if you get behind a little bit, pause it and then, get caught up with your notes or writing the stuff down and then hit play again. Okay. Okay. So what I have here, and we're going to do this mathematically first, is I have a point. Okay. And this is going to be my pre-image. And I'm going to move this point to this point on the graph. Okay, so this becomes my image, or, I start here and I'm going to end here. Okay, so what I do is I look at, a point's made up of an x and a y value. So I'm going to look at the x's. What change did I have between this first x value and the second x value? Well, if I look at that, I think I add 3. Okay, so I'm just going to write that down. So for the x's, I add 3. And then I look at the y's. What did I do to where I start and where I ended up? How did I move that point? Well, I moved it 6 in the positive y direction. Okay. All right. So that's going to become a rule. All right. And the way that I write the rule is, I am doing a translation here. Okay, so I'm just like, I call it giving it a shove. I'm shoving it somewhere else. So we're going to use capital T for translation. And then I'm going to use brackets that are a little bit different than I would use for describing a point. And in the brackets, I'm going to write down my rule. So I went positive 3 and positive 6. I went positive 3 in the x direction. I went positive 6 in the y direction. Okay. So now that I've created a rule, I can use this for other things. So what I have is now I've got this second point. I want to use the same rule. What point will I end up at? Okay. So I'm going to take this 12. And I'm going to take my x value rule, I'm adding 3. So that 12 now becomes 15. Okay. And then I'm going to come back to my y and repeat that process with the y. I'm going to add 6 to that. It gets me 16. So now I've ended up at that point. I started here. This was my pre-image. All right. And this became my image of that point. Okay. So I'm just shoving it. I'm giving it a push in a certain direction. I created a rule between these 2 points that I had, and I was able to use that rule with a different point. Okay. The big thing here is we're going to identify how I'm moving it. Like I said, we're going to get reflections. We're going to get rotations. Eventually, we're going to get dilations. And we use those letters to kind of indicate this is what you're doing. These brackets that we use also kind of give away what I'm doing as a translation. That's the only time we use those. You'll see those again when you guys get into algebra classes. We do vectors. It's kind of like slope too. I'm going x value, y value. It's kind of like rise and run. It's doing the same thing, just a little bit different way. Okay. All right. So if you look at B, why don't you guys take a look at that? Look at the change in x. Look at the change in y. Create a translation rule, kind of like what we did here, and apply that to this point. Okay. So you want to hit pause and do that on your own, or write that down and then do it. And then I'm going to start with the solution. Okay. All right. So I'm going to look at my x value here, and I'm going to look at my x value there. How did it change? Well, it looks like it got smaller or it decreased. So it looks like I went in a -1 direction. Okay. I look at my y value, it starts at -3, but then it goes to +2. Well, to me, that's a difference of 5. We got to be a little bit careful with our math here. I went in a +5 direction. Okay. So there is my rule. I'm going to use the funky brackets here. I'm going to say that I translate it using the capital T. And then I'm going to apply that rule to this point that I have right here. So I'm going in the -1 direction from -4. So that's going to give me, I believe, at -5. And then I went in the +5 direction from this y value. Right? So I believe that gets me to 8. Okay, so just really some simple adding and subtracting gets me to that point. Okay, so here we go. I jumped the gun a little bit on this just so we can get going here, but that's how we write a translation rule using capital T. Then we use these brackets, and you have an x value, you have a y value. A +2 means I'm going to move right 2 spaces, and a -3 for the y value tells me I moved down. Okay. All right. So if you have, hopefully you got some graph paper or something, but we're going to draw this graph. The arrow says I'm taking this triangle and I'm moving it in that direction. So I'm going to call this the pre-image. That's where we're starting, and this is going to be the image. Okay. Now, I'm going to do this kind of backwards here. The second question here, does it appear to be a rigid motion? So remember, a rigid motion means, are all the lengths of the sides the same? And do you think all the angle measures are the same between the two triangles? So to me, it looks like they're the same. You know, if we count squares, I'll start here. I got 1, 2, 3, 4, 5. The same course. I'm sorry, 1, 2, 3, 4, 5, 6. The same corresponding side over here, I got 1, 2, 3, 4, 5, 6. So to me, it looks like it's the same, but it has to be the same for all. You know, so if I did the bottom here, 1, 2, 3, 1, 2, 1, 2, 3. Come on. Looks to me like it stayed rigid. It stayed the same. Okay, so if it does look like that, what I'm going to do is I'm just going to pick one point. So I'm going to pick this point on the top. I'm going to identify it. To me, it looks like it's 1, 2, 3, 4. That point up here is -4, and 1, 2, 3. So that point's at 4, -4, 3. The corresponding point on this other triangle, I believe, is right here. So that point's going to be at 1, 2, 3, 4. And it's going to be at 1, 2, 3, 4, 5, 6. Okay. Good there. So now what we want to do is we want to write a translation rule. How did my x values change? Well, it looks like I moved right, so that's in a positive direction. And the distance from -4 to +4, I believe, is 8. Okay. And then I look at my y values that went up in a positive direction and went from 3 to 6, so I believe that's 3. So now I have a translation rule. Okay, well, that would then let me take that and go ahead and find this corresponding point and that corresponding point. I should be able to go, 8 in the positive x direction, then up 3 in the positive y direction, and get me from this point to that point. And I believe that's going to be correct. I then would want to repeat that process from here to here. I believe I go 8 in the x direction, positive, and up 3 in the positive direction for y. Okay, so that's how you do a translation. That's how we would use a triangle. Each point, I use the vertices, does the same rule all the way through. Okay. All right. We go here. We're given a translation rule right here. So if you want to write that down, we're going to go in the negative x direction 2, and we're going to go in the positive y direction 4. And if we write A and B down, they're asking in A, what is the image of 4/8? So I want to just take that translation rule and apply it. So I'll let you guys go ahead and do that. So if I take the x value 4 and it tells the translation rule says go in the negative direction, I'm really subtracting that. So I'm going to end up at 2, positive 2 for the x value. But the y value tells me to go up 4. So 4 in the positive y direction, which really means I add. So I'm going to get 12. So 2, 12 would be the new point or the image of where I started. Okay. All right. Now this is one. It's the test question that comes up. So make sure we do this to see if we're reading and understand stuff. They want to know what's the pre-image of this point. So this is really my image point. This is where I ended up. So it really wants me to go backwards. Okay. So it wants me to take. I'm still going to use this rule up here, but I need to use it backwards. So you know, thinking about that, if I want to go backwards, then I have to really change the signs. Okay. So really, I'm going to take that translation rule and go backwards. So I'm going to change the negative 2 to positive 2, and take the positive 4 and make it a negative 4, because I need to go back to where I started. They're telling me you ended up right here, but where did you start from? So I have to kind of go backwards. So I want to add 2 to that. So I believe 2 and negative 2 gives me 0. And I want to subtract 4 from 3. So that's going to give me negative 1. Okay. All right. So that's a little tricky. Make sure you got to know your vocab and be able to apply it to what they're asking you to do, and use some kind of common sense there. Okay. All right, we're going to take this triangle. We got 3 points. We're going to go ahead and graph it, and then we're given a translation rule, and we're going to graph where it ends up at. Okay. So if you want to hit pause and do that, and then I'm going to start with the solution. Okay, there's the point. They give me a translation rule of negative 2, 5. So I need to move each point negative 2, 5. Okay, I'm going to start with C because it was off the graph. So negative 2 in the x direction is going to make me go from C, make me go left 2, but then it tells me in the y direction down 5. So I believe that gets me here. And what we do too in using this stuff, when I move it, we use these little apostrophes. They're actually, we use the word prime to signify, hey, if I don't have a prime symbol there, this is where you start, this is where we ended. Okay, so just to kind of signify where we're going. And then I'll use a lot different colors sometimes. Okay, for B, I'm going to go in the negative 2 direction, and then in the negative 5 direction. So that's going to get me down to here. Okay. And then for A, I'm going to go in the negative 2 direction from here and then down 5. So that I believe that gets me to about here. And then I can draw my triangle. Okay. So I've translated it. So like I kind of said earlier, I think of giving it a shove. So I took the green triangle and I shoved it left and down from my translation rule. Okay. All right. So once you guys go ahead and draw this out, we're giving you 2 figures. We're starting at one place with the pre-image and getting to another place with the image. So the little apostrophe symbols that are here, that means that's the new one. Okay, so that means I went in this direction. Okay, so go ahead and draw that, and then you need to come up with the translation rule. So if you want to pause it and do all that, I'm just going to get going with the solution. Okay. All right, so to me, it looks like it's a rigid, and they're telling me that it translates onto it, so I'm just going to kind of start there. So I really only need 1 point to do this. If it's rigid and everything else, they said, hey, we translated it. I just need to come up with the rule. Pick a point. You could pick any point you want. So I'm going to choose the P and the P prime, okay? So I'm going to start with my X values. I'm starting at, I believe this is -3 on the X axis, or the X negative -3 on the X side. And I got to get all the way over, I believe, to +5. Okay, so I believe if I put that together, I get 8. You know, and you count squares. Let's count squares so make sure my math's right. So 1, 2, 3, 4, 5, 6, 7, 8. And then from there, I had to go down 2, but that's the Y direction. So my Y part of this rule is -2. Okay. And what I would do, you know, just to be safe, I'd pick another point and just see if that same corresponding points map onto each other. So the easy one I think is R and R prime. I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8, and down 1, 2. So I think we're good. That would be your translation rule. Okay. All right. So for that one, you know, just pretty easy. It's kind of slope-wise. Just want to really make sure that you understand how to write the translation rule. And then that one where we had to go backwards, so you just kind of flip the signs and go ahead and go backwards if you've given the image, but you got to get the pre-image. So they're giving you the end point, you got to find the start point. Okay. All right. Make sure you do a good job on your classwork. If you need any help, just get a hold of me and we'll get it figured out.